Hey guys, so welcome back to your next class of Catalyst Concepts. Today we will be starting a new chapter, and that chapter's name is Metallurgy, right? Metalurgy. You get some hint from the name itself what metallurgy could mean, right? So name has metal, so it has something to do with metals indeed. Okay, so what are metals? We've studied about metals or metallic nature in our previous chapters, right? And we also know that there are metals that we use daily in our life. Let's say your appliances are made out of metals, your utensils are made out of metals, the houses that we live in, they have these metal bars in them. So a lot of things that we utilize depend on metals. Even your wires are basically just a thin long metal, right? So metals were actually so useful to us that back in the early times before metals were discovered, every time people were able to find a new metal and use its properties to create something that could change their way of life, it brought in a new age. Okay, it was like a whole different change in the way that people were living back then. That is why if you ever come across these words iron age or bronze age, all of these are basically times when everything changed simply because people are able to find a certain metal in nature and use it to change the way that they live or just change the way they do things, right? So back then maybe like a handful of metals were discovered, but as is with the nature of discovery, over time newer things keep getting found out, right? And we are still finding more and more, maybe not metals but definitely in every sense we are trying to find new things, right? So as of now, of the 118 rough elements that we have or we have learned about in the periodic table, about 75% of those are metals. Okay, about 75% of those are metals, right? Now, metallurgy, if I talk about this term, is nothing but how do you extract metals? So, extraction of metals from their ores. Okay, this is a definition of metallurgy. Basically, on how do we get metal for ourselves to use. That's basically what it's trying to tell you. Okay. So extraction of metal from its ores is metallurgy. We'll just come to the terminology in a little bit. Okay. Now, when it comes to metals, where do you find them? Right? Do you find them freely in nature? Do you find them flying around you in the air? No, obviously not. You won't find them roughly anyway. Right? What if I try? See, there's pretty much only one place you can look in the earth, right? Inside the ground. If it's inside the ground, you have it. Or if it's in the water, you have it. Right? In the air, you may or may not have it. At least something like a metal. So pretty much for metals, this is what we do, right? We go and look into the ground, right? And in this ground, you will definitely find metals. But the question is, do you find metals the way you normally see them? Say if I give you a brick of gold, right? Will you find the same brick of gold in the ground just like that? Right? You won't find it just like that. That is something that we make. What about iron? Right? Say if you have a big rod of iron, do you find iron rods in the ground that you can just dig up and use directly? Obviously not, right? That is not how nature works. Now, when we studied about properties of metals, we studied that metals are reactive in nature. Actually, these are some of the most reactive species that are there in the entire table. Since they are reactive, they generally tend to give electrons. That's what we have studied about metallic property, right? Because of that nature of giving electrons, they'll be combining with other elements that are found around them. So that is why in nature, when you find a metal, it's never in pure form. You'll never find a pure metal piece anywhere in the ground. It will always be combined with some other thing that will be around it, right? Say these combined whenever you find these metals that are combined with something else, that is what we call as a mineral. Okay, so metals combined with other elements, okay, they are nothing but minerals. And there's lots and lots of minerals. There's so many that are there that we can talk about. And it's not just in the land, even in the water, right? Say there are, for example, we know that sea salt, sea water has something called sea salt, right? Salt water is tasty because of, sorry, salty because of that salt in it. There's nothing but sodium chloride, and sodium is nothing but a metal, right? So even in the water, you'll find a certain type of salts, which are also minerals. Basically, they're compounds that have metals in them. Okay, so let's take a slight look at this. Okay, so look at this image over here. These are like different types of minerals that you can find inside the ground. Okay, so when you're mining, when people go for mining, they're actually looking for things like these, and this is how they look. Okay, this is not at all like a pure metal. Okay, there's something called arsenopyrite, this barite, this bismuthite, bauxite, borate. These are all just metals combined with something else and forming something that looks like this. Some of them actually look quite pretty. Look at this. Look at this rainbow pyrite. Look how pretty it is, right? And there's molybdenite, there's perovskite, magnetite. There's so many really beautiful things that are found. Now, all of these are some sort of mineral forms, right? But we said extraction of metal from ores. What is this ore then? Okay, so any metal will form more than one type of mineral. Okay, most metals form more than one type of mineral. For example, if you talk about iron. Okay, so here is a small table of minerals. Okay, the name of the mineral is called hematite, and its formula is Fe2O3. Okay, in this, by weight, it is 70% iron. Okay, the rest 30% will be oxygen and maybe a little bit of impurity here and there. Okay, if you talk about magnetite, this is Fe3O4. It's a different formula, and it has 72.4% of iron. This limonite, which is Fe2O3.3H2O, 59.8% iron. Siderite, that is nothing but iron carbonate, and that is 48.2% of iron by weight. Okay, means a little less than half of it is iron. Rest half is just carbon and oxygen. Now, all of these are considered as minerals, but only out of one or two of these, you will actually be able to extract the metal in a feasible manner. By feasible, we mean it takes money to do all of this, right? It costs to buy the ore, to get the ore and then to process it, right? Unless it has a higher percentage of metal, it's no point. There's no point spending so much money and effort to just get half of the weight in metal. Meaning, if I have like 1 kilo of iron, I'll only get half kilo from siderite. Whereas if I have like a kilo and I use magnetite, I'll get almost 73%. That is 730 grams of this iron out of it, right? So obviously we are looking for more profitable ways or more cheap ways to do it. So any mineral from which it is profitable or from which it is feasible to remove the metal is called as an ore. Okay, so ore is nothing but a mineral from which extracting means removing, okay, is feasible, meaning we can afford it. Okay, so technically all of these are minerals, like these rocks that we see, but not all of them are ores. Only some of them will be ores. Okay, like for example, bauxite is an ore of aluminum. Anything else over here that has aluminum might not be an ore. It will just be a mineral. So bauxite is both a mineral and an ore. So one statement that can come out of here is that all ores are minerals, but all minerals are not ores. Okay, because all of these are minerals, but only some of them will be ores. Okay, and that will again depend on the process that is used for removing the metal and how much metal is there in it. Okay, now it's not simply just quantity, it's also about like the process that is involved in it. All right. So these are a few definitions that come to this process. Now, one question is different metals are forming different ores, right? And there's a different reason also why. So I'm just going to show you a list of these common ores. Okay, so copper has these ores, right? These are the names and these are the chemical formulae. This is for iron. So if you say iron, only use hematite, magnetite, because these are the ores that we use. We don't talk about these minerals anymore. Okay, we're just talking about the ores. Now, all of these are different ores with different formulae, right? But if you see sulfur is one thing that is very frequently occurring. Sulfur and oxygen both, right? A lot of ores will actually form with sulfur, both sulfur and oxygen. And sulfur and oxygen are actually in the group 6 called as the chalcogen group. It's nothing but means forming ores. Okay. Now, ores can be of sulfate, can be oxides, can be sulfides, can be carbonates, can be chlorides. There are different types of metal ores. And what type of ores they are will depend on what metal it is and where it is found. Okay. And sodium is more of a chloride ore, or you find NaCl, something like that. Okay, so depending on how they react with others, there is something called as reactivity series. Okay. Now, reactivity series is nothing but, since all metals are different, some of them are more reactive, some of them are less reactive. Okay, so you'll find some metals are highly reactive, some are moderate, and some are low. Okay, if I talk about highly, you'll find things like sodium, potassium, calcium. All of these are highly reactive elements. Okay, if you come to moderate, it's something like iron, yeah, copper, all of these, zinc. These are all moderately reactive metals. And low reactive are nothing but silver, gold. All of these are low reactive. There is also a chance of finding low reactive metals in their pure form. Okay, highly and moderate you'll almost never find in the pure form. Actually, never you'll find them in the pure form in nature. But gold and silver, you might find tiny amounts of pure metal in the nature, just because they're very low reactive. Okay. So depending on each of these, we'll have different processes. In the next class, we'll be talking about what is the process that is followed when it comes to extracting these metals from all of these ores. Okay. So this is where I'll stop for today. Introduction to metallurgy. I hope you understood. If you have any questions, doubts, please drop them in the comments below, and I'll see you again in the next class. Thank you very much.